Hello and welcome to Transforming the Factory, Part 2. I'm Bob Treblecock. I'm the executive editor of Modern Materials Handling, and this is the second of two podcasts brought to you by Norgren that will look at the transformation of manufacturing and the factory of the future in the new digital era. Now, if you're not familiar with them, Norgren is a respected leader in the fields of precise motion control and fluid technology, with customers across more than 50 countries in areas such as factory automation, material handling, commercial vehicles, rail, life science, energy, and process control. From improving speed, productivity, reliability, and efficiency of equipment to generating significant energy and cost savings, or lowering total cost of ownership across many industries. Norgren's solutions are designed to help customers pursue progress, achieve new goals, and overcome challenges. Norgren offers insight, technical excellence, and a collaborative approach to help customers forge a brighter future possibility. Now, joining me once again are two experts in smart manufacturing and digital transformation, Kandice Lord and Abhinav Agrawal. Now, if you didn't listen to episode 1, I really encourage you to go back. We had a great conversation outside the four walls of the warehouse. Kandice is a director at Alix Partners, where she specializes in holistic transformational change and helps companies navigate the complexities of operational transformation and manufacturing turnarounds. Abhinav is a partner and managing director at Alix Partners with experience in delivering large-scale, digitally enabled business transformation for manufacturers across the globe. He is a pioneer in applying agile principles and digital technologies to improve clients' manufacturing operations. So, Kandice and Abhinav, welcome once again.
Thanks, Bob. Great. Thanks for having us.
Well, thank you. Now, as I mentioned just a second ago, in the first episode, we stayed outside the four walls. We concentrated on the drivers of the transformation of manufacturing. Today, we're going inside the four walls to talk about automation and the next-gen technologies that are making the smart factory a reality for companies large and small. This is the fun stuff. So let's get started. I want to start with the same question we led off the last episode, but with a twist. So first, just what is a smart factory? Abhinav, let's start with you.
Thanks, Bob. As we discussed in our last session, there are many definitions of smart factory floating around, and naturally, there is a lot of confusion. The real definition of smart factory is a highly automated and data driven manufacturing facility that leverages technologies such as automation, Internet of Things, artificial intelligence, data analytics to optimize operations, enhance productivity, and respond to changing market needs. In essence, the use of automation, Internet of Things, and advanced analytics is what makes Smart Factory smart.
So, Candice, the twist. When we talk about manufacturing, we're still talking about making stuff, moving stuff around a factory. When we talk about digital manufacturing, it almost sounds like, we're doing that all on a computer, but you still got to make stuff. So what does digital manufacturing mean?
So, like Smart Factory, Bob, there are a lot of misconceptions about digital manufacturing, with it often being used as a buzzword by many, but frequently misunderstood. I'd say at the highest level, digital manufacturing is a broader term than smart factory. It refers to companies leveraging digital technologies to optimize various elements of the manufacturing process. And that includes upstream design, product innovation, production, all the way through the downstream servicing of the final products. The aim of digital manufacturing is to make the different elements of manufacturing execution more efficient, flexible, and responsive to customer demands. And although it includes many of the elements and technologies associated with a smart factory, like Internet of Things, artificial intelligence, digital twins, robotics, all of that, smart factory is a subset of digital manufacturing. And goes beyond the use of these technologies within the four walls of the factory, so to speak, and includes both the upstream and downstream elements of manufacturing execution.
So, Abhinav, when we talked yesterday, one of the things I asked, we were again talking about the outside forces. One of the things I asked was, this sounds a lot like it's applicable to big global manufacturers, but is it applicable to the small to mid-sized manufacturer? And you and Candice both had some great answers to that. So now inside, there's this perception that automation, robotics, and other technologies, they're going to cost millions of dollars. They're going to take years to implement and deliver an ROI, so that they're really only available to the big guys. Are those just myths? And if so, why?
It is definitely a myth, Bob. Business press and even readers love to cite and read outlandish examples. For example, there was a lot of press about Amazon deploying 520,000 robots at the expense of more than $1 billion. Even when Amazon back in 2012 acquired Kia Systems, the automated AI driven robotic system, for $750 million, there was a lot of press. But all these things leave out the examples like Unilever's laundry detergent powder factory in Brazil, a mid-sized factory which has been awarded by World Economic Forum as a lighthouse status. Just for clarity, since 2018, World Economic Forum has created a prestigious lighthouse status for the most advanced factories in the world. And Unilever's laundry detergent powder factory in Brazil is not one of the highest tech, highest invested, but still got that by applying practical digital solutions. And why is it possible? Because only few of us who are in the field know that technology has truly democratized the digital realm. In recent years, cloud platforms, for example, Microsoft Azure, Amazon Web Services, they have all brought in sophisticated cloud computing capabilities within the hands of every company. Sensors and cameras that once needed to be custom built for the factory applications can now be acquired and adopted inexpensively. These changes empower enterprises of all size with the state of the art tools for smart factory cheaply.
I've talked to a number of companies about digital transformation, and it seems that the only thing they share in common is that they all had a different starting point. Some of that comes from what's their go to business model, what is it that drives their business, kind of creates a starting point. But it seems as if nobody picks the same place to start. So if I'm a company, large or small, listening to this, how do I identify the starting point for my digital transformation?
Yeah, it's an excellent question, Bob. And building off of Abhinav's comments, it's critical for companies to start with an understanding of the business challenges and then build from there. So many times, though, I think the reverse happens. Companies often top down from the board or otherwise have some desire to keep pace with the advancing technologies. And so money just gets thrown at anything digital without a thought. Like anything else, the foundation is key. So the starting point should be a clear identification of challenges the business is facing. So assessing what the existing capabilities are, where these struggles across the value chain exist, and then prioritizing the value effort opportunities. Once that's complete and there's a clear view of what the challenges are, the value creation tied to those challenges, and the feasibility of executing, only then are companies truly equipped to tailor solutions to their needs and identify the tools and technologies that should be implemented. And as you mentioned, right, everyone will have a different starting point based on where the company is today and what challenges exist. And so this shouldn't be viewed as a one time exercise. As companies continue to evolve on their digital journey, it's really an iterative process that focuses on just constant reassessment, reprioritization, and an agile mindset.
So, last foundational question for all of this: is it always about technology? So, here's my example. I recently had an opportunity to interview a number of executives from Procter and Gamble about their operating system. And Procter and Gamble, uses a lot of technology. When you go to Gartner, they basically say, yeah, pretty much everybody here is somewhere, in our ecosystem. But they also say that the starting point for them is always to make sure their equipment is operating, as delivered or as specified when they ordered it, and then that their process is sound. And only after they've addressed those two things, they've got a sound process and they know the equipment is operating, as efficiently as it can, then they look and ask the question, well, if we had a technology, what would take us to the next level? So, how do we approach technology?
Yeah. So, Bob, it is not just about technology, it is about people, process, and technology all working in harmony. More often than not, the biggest ideas and biggest the solutions with most impact are often when you combine people, process, and technology together. However, before prioritizing any of people, process, or technology, all of them collectively, we should first look at the bigger picture. That is profit and loss P&L statement. We help our clients first identify the opportunities with the largest P&L impact. It could be material waste in one plant, it could be lower OEE for the other plant. Only once we understood the drivers of P&L, we apply agile principles that combine people, process, and technology to drive step change that produce breakthrough results. A case in point to illustrate this point. One of our clients, one of the largest manufacturers of food products, had an adverse P&L impact due to rise in food ingredient during in the wake of the war in Ukraine that we all know. During problem solving agile sprint, we recognize that no one in the room can influence the price of wheat. I mean, it's out of our control, a key ingredient of the product. However, we can control the process better to reduce waste and overweight. Then we identified technologies, in this particular case, IoT sensors and cameras, that can help improve the process. And in the end, we assigned individual ownership for the reduction of waste and oversight. Now, this combination of people, process, technology, all working together at the same time resulted in 25% reduction in waste within 3 months. So you don't need to wait for very long to get the results. Hope this case illustrates to listeners that prioritizing people, process, or technology before understanding P&L issue is like putting cart before the horse.
Candice, so something I mentioned early on is manufacturing is still a physical process, right? We have to make and deliver widgets. But one of the technologies we hear a lot about is digital twins. I'm going to pack a lot into this question, but first, what is a digital twin? And then how does it enable me to optimize my operations when I do physically make and deliver a widget?
Yeah, it's a great question, Bob. I'd say a simple definition of a digital twin is a virtual model designed to accurately reflect a physical object. And these virtual models are built with and based on data. They're often created using technologies like simulation software, so example, computer aided design, and they're aimed at replicating the characteristics of the real world object, system, or process. The use of digital twins has gained a lot of traction due to its potential to improve efficiency and productivity, as you rightly highlighted. I'd say one example where digital twin can be used to optimize operations is in manufacturing. So, physical machines can be equipped with sensors and Internet of Things devices that basically capture the data on a continuous basis. That data set effectively becomes the foundation or real time digital counterpart of the machine it was collected from. And so digital twins can simulate and model a production line, for example, with different simulations being run to optimize production, reduce waste, perform predictive maintenance, all by analyzing that data and simulating this virtual environment from a digital twin. The organizations can then predict maybe when maintenance or repairs are needed. They can reduce downtime and even just extend the lifespan of assets.
Abhinav, we're talking a lot about technology. So whether it's digital or mechanical, like robots, what in particular are you watching, or do you think holds promise? What's ready for prime time?
Bob, as we discussed in our last episode, I feel like this is an exciting time for digitization and automation. And I do believe that we'll continue to see advances in industrial robots, edge computing, cloud-based data processing capabilities. But for me, the technology that holds the most promise for manufacturing is generative AI. I know there is a lot of buzz around the technology, and many in manufacturing, especially, don't think it applies to them. But I've already seen one example that I'll share, which gives me a lot of hope around this technology. So our client, one of the industrial and consumer tool manufacturer, had seen reduction in labor productivity and quality due to worker training issues. The problem was exacerbated by high labor turnover, and loss of experienced worker during COVID. Our client built a TikTok-like training platform for young generation of employees on the back of generative AI technology. The platform allowed individual workers to upload 30-second or less videos, how-to videos. Generative AI reviewed those videos for safety and other compliance, making sure that these videos don't violate some of the egregious things that needs to be there, and then combined videos from different workers as a comprehensive training course, and then even translated the audio and captions in multiple languages. The platform was quickly adopted by more than 20,000 plant workers, admittedly mostly younger plant workers, but a lot of them were even from our generation. And the 20,000 plant workers across the globe, and it resulted in significant quality and productivity improvements within 6 months. That's why I'm very excited about this technology.
Thanks for that. Kandice, I'm going to go back to this notion that it doesn't have to cost millions or take years to deliver. Abhinav gave us, one really great example. Can you think of a couple of other examples from your client list where they've gotten early wins?
Yeah, one that comes to mind, Bob, was a baked goods manufacturer who implemented multiple small but very successful initiatives over a very short period of time. So we're talking less than 6 months. And it delivered over 4 million in run rate savings due to reducing waste. Some specific things that were implemented, one, they utilized IoT enabled scales that costed, just $200. And that was used to generate real time email and text alerts to supervisors, allowing them to take immediate corrective actions for any overweight product. Prior to that solution, they were using paper based quality assurance processes. So, although the data and variations were being captured, it didn't allow for real-time intervention and correction. So this, very simple solution demonstrated immediate results. It generated a lot of excitement internally and was then scaled across their other manufacturing lines and helped to really secure the buy-in for future initiatives. A couple other technologies that were implemented, including, vision systems, also used for reducing waste, virtual factory training, similar to what Abhinav mentioned, real time sensors to help optimize utilities. So, again, it was a win win across the board with a series of small initiatives that helped, fuel the momentum for future initiatives that were later implemented.
Abhinav, I really like these examples because I think they drive home for listeners, what can be accomplished. Can you add another one?
Sure, sure. One of our client, uh, an auto care products manufacturer, experienced a significant drop in OEE as unplanned downtime increased. The machines were breaking down. They had 6 production lines, and the OEE actually dropped to about 50%. Um, we quickly built an AI model that analyzed maintenance history. The model was very quickly, within weeks, was able to start predicting failure of plant equipment, all the equipment in the plant, with 80% accuracy. Not 100%, 80%. But the plant, the this model, we use this model to create maintenance tickets and assign it to maintenance team. And so that and we also measure the effectiveness of maintenance team to address those tickets. The OEE improved from 50% to 75% within 3 months of deploying the solution. Now I know that model was 80% accurate, so team was probably doing 20% extra effort. They were repairing 20% of the time. They were repairing things that didn't need repair. But the impact of OEE going from 50 to 75% far offset any of that 20% cases. And that is another example of how we can very cheaply deploy these solutions and get quick results.
So, last question. I'll let you both take a swing at it. We'll start with Kandice. Just any final piece of advice to companies beginning their digital journey? Again, Kandice, take it away.
Yeah, so 3 points I think companies should keep in mind. One, regardless of the starting point, a profit and loss centric approach will drive the most success for the program. The companies that are prioritizing value creation at pace are the ones that are able to deliver fast results that still align with long term business goals. So that'll be the first one. I'd say, secondly, expectation setting upfront needs to be pragmatic and specific. So companies need to get honest about where they are, what the challenges are, and then prioritize accordingly. While ambition and aspiration are valuable in driving digital transformation, setting goals that are too high without considering the baseline, practicality, and incremental progress can really increase the risk of program failure. And then I'd say the last thing I'd highlight is digital transformation needs to keep pace with customer expectations. We live in a period of time where we have access to technology that can solve our complex problems like never before. And customer expectations rise, but their willingness to pay incremental dollars for the experience is not always a given. So being in sync with the customer needs and incorporating that into the digital transformation journey is critical.
Abhinav, take us out.
Yeah, so I think Candice covered all the major pieces, but I would like to add one, which in my view is the most important one. Smart factory efforts must be led by a manufacturing leader and not a technology one. I come from technology background, so and I've seen a lot of efforts led by technology leaders and fail. I think smart factory is slightly different, and that's why it should be led by a manufacturing leader. The best leaders for smart factory initiatives are experienced executives who combine manufacturing pragmatism with digital savvy. So they need to learn digital, but it's easier for manufacturing leaders to learn technology. Too many balance sheets show off or show write off for factory modernization that didn't deliver the goods, sometimes literally. In this case, in this respect, senior leaders are closer to operations, both experientially and physically, are best suited to lead the digital effort.
Well, thank you. That's all the time we have today. I want to thank Candice Lord and Abhinav Agrawal from Alix Partners for joining me today. And I'd like to thank Norgren for making this possible. Finally, remember that this was the second of 2 episodes on transforming manufacturing. So if you haven't done so already, be sure to listen to episode 1. It'll put this all in context. For Modern Materials Handling and Norgren, I'm Bob Treblecock, and Kandice and Abhinav, thanks once again.
Thank you.
Thank you, Bob.